I just want to go back to the computer flattery issue, where the computer sort of, when you've made a mistake, it doesn't explicitly say that, but it kind of leads you. So in psychology, we know that people can have an overly inflated sense of self-esteem that's not really based in reality. And what you're describing will promote that overinflation, which has issues both for the person and then for society, because if a computer so nicely tells me about my mistakes that I don't even realize I've made them, why would I ever want to interact with a human?
But there's two parts of that question. One is, yeah, that scares the hell out of me. The other one is, why, if I'm selling this stuff, wouldn't that be exactly what I would want to be true? Right? In other words, like if I said to you, I can invent a product that people will love, will want to use 24 hours a day, you can charge by the minute or whatever, or not. As a company, right, you could say, sounds good. Now, you could argue societally that's dangerous and bad, and I'm part of the society, so I probably agree. But it's a really interesting question. You know, how nice should we enter a society where technologies can be, and in fact, right now probably could be nicer than a friend. Maybe not as close as good as your best friend. And the answer is, we're entering that to some degree. And there's a sense in which Facebook is already creating that environment. It's smoothing out, texting, in fact, even better. So I talk with a lot of the kids in my dorm, and they basically say, you know, the nice thing about text a lot of the time is I don't have to deal with people's emotions. Now, is that a nice thing about text, or is that a scary thing about text? And it depends on how you're feeling at that moment, right? And so I think that you've hit upon an important issue, but I don't think there's a black and white answer.
This is true about technology in general. It can be used for good things, and it can be used for things that aren't good. And somehow that decision is a policy decision that stands outside the capabilities of the system.
So I'm interested in the blame, and specifically in the context of two things that you said. One was about the system needing to have a shared goal, and the second one about the fact that smart systems make more mistakes because they're trying to do harder things and ambiguous things. And so then I'm thinking about the two examples that you gave of the car and of the medical system. Mm-hmm. So clearly the company that makes the system and the individual wins when it gets it right and you avoid a drug error or slamming into things. Mm-hmm. However, when it gets it wrong, which it has to do some of the time, now there's an issue of blame, and the shared goal is no longer there. I want to protect myself from being sued, so I might, give you too many messages or do other things that are, and so I'm curious about how that breaks down, whether we like systems more that are willing to accept blame, those sorts of things.
So I think you're asking two different questions. One, I'll let Cliff answer, which is what we like, and the other is how, from the technology point of view, we build these systems when there might be something that goes wrong. So it's pretty clear in many of the health informatics systems that I've looked at and physicians that I've talked with that people have bent over backwards to be protectionist of the system. That is, they don't want the system, or the builder of the system never wants to be able to be blamed for anything that goes wrong. There's a subtle problem here, though, which is that if the physicians using the system can't use it because it's so onerous, either, as some of them have told me, they just turn off certain features. So they're writing things on their hands or pieces of paper and then letting somebody else enter it because it's so onerous. Or they'll make mistakes because they're being asked to do things that they're just not good at doing. So I think that's really, again, it's not an issue of what the technology can do. It's an issue of how you want to design the overall system. Now, there is, I think, one of the biggest challenges in designing smart systems is designing them to be smart enough to know when they don't know enough. And that arises in this situation as well. And as Cliff said earlier, that's one of the things that Siri is somewhat clever about. And that system is able to be clever because it's very constrained in what it does.
So I think of this in terms of what I call the Hal Syndrome from 2001, right? So Hal, the road, does these terrible things, and people blame him. But so I was at NASA watching them talk about moon colonization, and they had an astronaut and a robot working side by side welding. And at one point, the astronaut said, robot weld over here. And it was a demonstration of natural language understanding and the fact the robot was smart enough not to move its torch in front of the astronaut and burned him, etc. Okay. So I then said, that's really cool. That's awesome. But what if the robot thought he was better off welding where he was? After all, he's got infrared vision and da-da-da-da-da. Why? They were like, oh my God, a robot can never disagree with a person. So I said, well, why? They go, well, haven't you seen 2001? But it's fiction, right? And then they say, okay, well, all right, but what about Asimov's Laws of Robotics? You know, haven't you seen that? I said, love those books, awesome, read them all. Fiction, like we have no idea. And what was cool was I literally called the NSF program director that day and said, there were loons here. Please give me some money. And it was the first and only time I ever got one-day turnover money from NSF to study blame in robots, where a robot could actually say, you're wrong and I'm right, okay? And it turns out that, in fact, interestingly, for the most part, it's very tough for a robot to pull off. So they were doing a test together, and the robot said, you know, I actually think we'd be better off here. And people got furious. In fact, there's great video where as people were leaving the room in that condition, it was a robot about 3 feet tall, 3 of the subjects accidentally kicked over the robot, okay, which didn't happen in any of the conditions where there was no blame. So people hate this stuff. But realistically, to have a successful team interaction, a true team, not like, you know, sort of pseudo teams, you've got to be willing to accept the fact that sometimes someone's going to disagree with you. It's part of, you know, growing up too. And so I think that's going to be one of the challenges. We have it now, you know, where in these autonomous cars where the car takes over for you at some point when it judges it's safer. Okay, in other words, it decides it's better. People are livid. But to Barbie's earlier point, anti-lock brakes do that right now and have been doing it for 20 years, but no one knows. Why? Because it doesn't announce the fact. In other words, no, seriously, in anti-lock brakes, the car, you should all know, maybe it'll stop you from driving, when you press the brakes of an anti-lock brake car, which all brakes have now, that is merely a suggestion for the car to stop. And the car does whatever the hell it wants to do. And in fact, it's much, much, much safer. So it's the same problem, but the idea of like, you dare to take control, even though, right? And so this, I think, is one of the biggest challenges we have. If it's always going to be the case that we can, the computer can only be a surreptitious teammate, like, you know, do things secretly, etc., we're never going to really advance. On the other hand, every time systems do say, like, you know, ha, I caught you in an error, people get livid even if it's right. So I think it's probably one of the greatest challenges going forward.
There's one more question.
Yeah, I got it. So she mentioned earlier how, you know, with autocorrect, when it first comes up, then it seems, you know, like the most helpful thing in the world. And as you get more accustomed to it, then it becomes cumbersome. And you said the solution to that is that, you know, the technology has to accustom to that and be able to draw back. But when I think about this on a general level, my intuition says that for anything software could help us with, and there will also be cases where as we get more accustomed to whatever we're doing, then we're going to want the computer to take care of the little details so we can take care of more complex or more macro level stuff. So I feel like when we're addressing that problem in general, figuring out the mechanism of the computer becoming accustomed to the way the user performs sort of is the same. It's the same problem as understanding and being able to work out the mechanisms of human learning, which seems to be deeply challenging to me. So I was wondering if you had any insight on sort of how that kind of mechanism could develop or how it'd work. So
the first thing I'll say is I hope that you'll join in helping us do this, because it's a very good question. So what you want is for the system to adapt to the person, which is what we do when we work well with other people. There are techniques in the machine learning community for learning adaptation, learning over time what people are doing, what they're doing well and what they don't do well. So that's one automated approach you can take. But some of it is actually taking the right design stance when you're designing the system from the beginning. And you're right, they're hard problems. And I think it actually gets back to something that Cliff and I spoke about when we were talking about this session, which maybe is a good way to end, which is that we're basically scientists trying to uncover underlying mechanisms. And each of those scientific results we produce allows people to build better systems.
It also allows people to understand systems better. So there's really those two different kinds of outcomes. And some of the people who could understand better are the people, not necessarily the technologists, but the people who are designing at a larger level what the systems should be doing and trying to integrate them into either work or learning situations.
And the key here is, if you look at teams, what makes teams successful, a lot of it has to do with commitment. So if you feel like the other person is trying, so this is a well-understood phenomenon. If I'm working with someone, I feel like they're trying, even if they're not doing a great job, the team works well because I'll cover, but I won't announce, you loser, you bozo, I'm covering for you. And so how do you elicit commitment, which, Siri does by trying, this whole idea of trying. And in fact, that's one of the examples of the paperclip. One of the things that people reacted to most negatively with the paperclip is, I typed the same sentence again, and it didn't try. Okay. Now, of course, what does it mean for a computer to try is a really interesting question. But this notion of, if you feel like you're working together, tons of magical good things happen. And if you feel like you're not working together, tons of magical bad things happen. It doesn't even matter what the hell is really going on. So I think that's a large part of it.